There is a law so deeply woven into the intuitions of anyone who has ever studied physics that it feels less like a rule and more like a wall. Nothing moves faster than light. We teach it in classrooms. We repeat it in popular science. We treat it as the single most reliable speed limit in all of nature. And in one very precise, very specific sense, that is absolutely correct. But in another sense, one that general relativity makes unavoidably clear, the universe has been violating what most people think that law means since the very first fractions of a second after the Big Bang. Right now, as you absorb these words, there are entire galaxies, vast civilizations perhaps, that are receding away from us at speeds that mathematically and observationally exceed the speed of light. Not almost, not approaching, exceeding. And the reason this does not break physics is because the law was never about space itself. It was always only about motion through space. That distinction is not a footnote. It is the entire architecture of the situation, and once you truly feel the weight of what that means, your understanding of the observable universe and its absolute outer boundaries will never be the same. Let us begin by laying the foundation with complete precision. Einstein constructed the special theory of relativity around a beautifully austere central principle. The speed of light in a vacuum is constant for all observers. No material object with mass can be accelerated to that speed because doing so would require infinite energy. No signal, no information, no causal influence can outrun a photon traveling through the vacuum. This is the law. This is the wall. And it applies without exception to the motion of physical objects and fields propagating through the local fabric of space around them. The key word embedded in that statement, the one that unlocks everything, is through. The law governs velocity through space. It says nothing whatsoever about the velocity of space itself. General relativity, the far grander successor to special relativity, describes gravity not as a force, but as the curvature of a four-dimensional fabric called space-time. In that framework, space is not a passive, inert stage on which matter performs. Space is a dynamic, malleable, geometrically active medium. It bends in the presence of mass. It ripples when massive objects accelerate. And critically for our purposes today, it expands on cosmological scales. The expansion is not an explosion of matter into a pre-existing void. It is a continuous generation of new metric distance within the fabric itself. New space is being created between all gravitationally unbound objects continuously, and that creation process is entirely outside the jurisdiction of the speed of light restriction. To make this viscerally clear, consider a carefully constructed analogy. Imagine two small automated mechanical boats floating on the surface of a vast, highly flexible rubber canal. Each boat has an engine with an absolute built-in top speed of 10 miles per hour through the water. If both boats fire their engines toward each other, they close the gap at a combined approach rate and eventually meet. Their engines work perfectly within their limits. Now imagine that beneath the surface of this canal, hidden industrial machinery begins stretching the actual rubber material of the canal floor with enormous force. The canal itself expands. The water sitting on top of the rubber stretches along with it. If the machinery is powerful enough to generate 50 miles of new canal between the two boats every single hour, those boats are now being separated at 50 miles per hour. Neither boat has violated its engine limit. Neither boat has physically moved faster than 10 miles per hour through its local patch of water. The water itself, the substrate, is generating new distance between them at a rate that completely bypasses the localized mechanical constraint. No engine law has been broken. The boats are nonetheless being ripped apart at 5 times their maximum self-propelled speed. This is not merely an illustrative metaphor. This is, with high fidelity, the geometric situation occurring across the observable universe at this very moment. The galaxies are the boats. The speed of light is the engine limit. The expansion of space is the industrial machinery beneath the rubber, and the machinery is running at extraordinary power. The formal description of this process in cosmology is called the Hubble flow. Edwin Hubble observed in the 1920s that distant galaxies are receding from us, and that their recession velocities are proportional to their distances. The further away a galaxy is, the faster it is moving away. This proportionality is encoded in the Hubble constant, which describes the recession velocity per unit of distance. Every megaparsec of space between us and a distant galaxy adds a specific outward recession component to that galaxy's apparent velocity. At distances approaching and exceeding what is called the Hubble radius, approximately 14 billion light-years from us today, the cumulative expansion of all that intervening space pushes recession velocities past the speed of light. The engine driving this acceleration is dark energy. This is the name we give to a profoundly strange form of energy that permeates the vacuum of space uniformly and does not dilute as space expands. Ordinary matter and even radiation lose density as the universe grows, because the same amount of stuff is spread across a larger volume. Dark energy does not behave this way. Its energy density remains constant even as the volume of the universe increases. This means that as space grows, the total amount of dark energy grows with it, and its repulsive effect on the expansion rate increases accordingly. We are not simply coasting outward from an initial explosion. We are actively accelerating. The separation between gravitationally unbound structures is growing faster and faster with time, driven by this persistent, omnipresent vacuum energy whose nature remains one of the deepest open questions in all of theoretical physics. The consequence of this acceleration for communication across cosmic distances is staggering, and it forces a reckoning that is, once fully absorbed, genuinely disorienting. Suppose an advanced alien civilization exists in a galaxy located far beyond what cosmologists call the cosmic event horizon. This horizon is not a physical wall. It is not a surface made of anything material. It is a boundary defined by geometry and expansion dynamics. It marks the maximum distance from which light emitted today could ever reach us in the infinite future, given the current and projected acceleration of cosmic expansion. For galaxies beyond this horizon, the space between us and them is expanding so rapidly that even light traveling at full speed toward us from those galaxies will never close the gap. The photons will travel outward from their source, moving at the speed of light through their local space, but the space ahead of them, the space still separating them from us, will continue to generate new distance faster than the photons can cover it. The light is not being reflected. It is not being blocked. It is being continuously outpaced by the metric expansion of the very route it is attempting to travel. Imagine sending a swimmer to cross a river. The swimmer is fast and determined, but the river itself is widening at a rate faster than the swimmer can move forward. Every stroke closes some small distance, but 10 new meters appear for every meter gained. The swimmer never reaches the far bank, not because of any failure of effort, not because of any wall or obstacle, but because the geometry of the crossing is fundamentally working against arrival. This is the situation for photons originating beyond the cosmic event horizon. Their journey is geometrically forbidden by the architecture of space. Now sit with the existential weight of that for a moment. If an alien civilization in one of those beyond horizon galaxies built the most powerful communication array imaginable and aimed it precisely at the coordinates of our solar system, those signals would never arrive. The civilization could have spent millions of years constructing the transmitter. The signal could be encoded with the entire sum of their scientific knowledge. The photons would depart, obedient to every law of electromagnetism, traveling at precisely the speed of light through local space, and they would never reach us. Not in a billion years, not in a trillion. The expansion of space would continuously push the destination away faster than the message could travel toward it. The communication channel is not merely difficult, it is permanently and irrevocably closed. And this is not some distant hypothetical about exotic edge-case galaxies at the absolute limit of conceivability. Current measurements of the Hubble constant and the density of dark energy indicate that the cosmic event horizon sits at roughly 16 billion light-years from us. Vast numbers of galaxies already reside beyond that threshold. Their light, if emitted today, will never reach Earth regardless of how long we wait. Some of that light is being emitted right now by stars around which planets may orbit, on which life may have flourished for billions of years, and it is destined to travel outward forever without ever arriving at a human detector. There is another layer to this picture, one that adds a dimension of profound historical poignancy. Many galaxies that are currently beyond our event horizon are still visible to us today. We can observe them in our telescopes. Their light, emitted in the distant past when those galaxies were much closer to us, and the universe was younger and less aggressively expanding, has spent billions of years traveling toward us and has successfully arrived. We are seeing those galaxies as they existed long ago, when the geometry of expansion had not yet foreclosed the possibility of communication, but any photons they emit today, at their current distance, in the current expansion regime, will never reach us. The galaxy is simultaneously observable and already cosmologically severed from us. We see the ghost of a connection that the present moment has already closed. As time continues to pass, the accelerating expansion will progressively draw more and more galaxies beyond the event horizon. Objects that are today just inside the boundary will eventually cross over. The horizon is not static. It is slowly encroaching on our observable neighborhood, and over immense spans of deep time, the effect will be dramatic. Billions of years from now, even the nearest galaxy clusters beyond our own local group will have receded beyond contactability. The Andromeda Galaxy, gravitationally bound to the Milky Way, will remain with us, as will the other members of our local gravitational cluster, but everything beyond that gravitationally assembled island will dissolve into unreachable darkness. Future civilizations inhabiting our galaxy billions of years hence will look outward with their most powerful telescopes and see nothing, not because stars have stopped shining, not because the universe has ended, but because the universe will have expanded so thoroughly that no light from any unbound structure outside our local group will have been able to make the journey. Those future astronomers will have no direct observational evidence that the universe contains anything beyond their immediate gravitational neighborhood. The cosmic web, the large-scale structure, the billions of galaxies we map today will all be geometrically invisible to them. We are, in this sense, extraordinarily privileged observers. We exist at a moment in cosmic history when the universe is old enough to have formed stars and galaxies and planets and biology, but young enough that the expansion has not yet erased the light record of the broader cosmos. We can look outward and see the architecture of the universe on the grandest scales. We can measure the cosmic microwave background, the afterglow of the early universe, still arriving from distances of over 45 billion light-years. We can trace filaments of dark matter and galaxy clusters spanning hundreds of millions of light-years. This window of observational richness is not permanent. It is a cosmological moment, and it will close. What makes space expansion the most formidable separator in all of physical reality is precisely that it operates below the level at which any local countermeasure can be applied. You cannot build a faster rocket. You cannot develop a more energetic communication laser. You cannot engineer around it at the atomic or subatomic level. The expansion is happening at the level of the metric, the mathematical description of distance itself. Every attempt to cross the gap requires traveling through space, and space is the very thing generating the barrier. It is as if the road you are driving on is being continuously stretched beneath your wheels, adding new miles between you and your destination faster than any engine could cover them. Dark energy and the mathematics of metric expansion have together constructed a universe with a built-in communication horizon, a boundary beyond which no exchange of information, no evidence of mutual existence, no signal of any kind can ever pass. We are not being kept apart from distant civilizations by space as a distance. We are being kept apart by space as an active, expanding, accelerating geometry that compounds with every passing second. The speed of light is not being broken. The rule governing motion through space remains inviolate. But space itself has no such rule, and in that asymmetry between local physics and global geometry lies one of the most profound and underappreciated realities of the universe we inhabit.